Welcome to Honors Geometry Lesson 10.3, Properties of Chords. So we've talked about arcs and all kinds of things going on there. Now we're going to look at properties of chords, and most of the things that you're going to see today are going to be theorems. And you'll know they're theorems because the font color is purplish. Alright, so let's move right along. And these are just kind of self-explanatory. They're not necessarily theorems, but it makes sense. A non-diameter chord, like XY, will cut a circle into a minor arc and a major arc. XY would be the minor arc, and XZY would be the major arc. A diameter will cut a circle into two semicircles. Those two semicircles, remember with semicircles you need to use three letters as well. DFE and DGE. Those are the two semicircles. Alright, here come some properties of chords. These are theorems. In the same circle, or congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So if you know that two chords in a circle are congruent to each other, then the arcs are congruent to each other. So we could write the following equation, because we know the chords are congruent, that will make the arcs congruent. So 5x plus 2 equals 47. Subtract 2 from both sides and divide both sides by 5. But with this if and only if, it could also work the other way. So our equation would be 3x minus 16 equals x plus 33. Since we know the arcs are congruent, then the chords have to be congruent. Subtract 16 from both sides. Add 16 to both sides. Subtract x from both sides. Divide by 2. X equals 24.5. Next theorem, moving right along. If one chord is the perpendicular bisector of a second chord, then the first chord is a diameter. So if you look at segment VU, if you look at that chord, it bisects this chord here and is perpendicular to it. It's the perpendicular bisector. Then VU has to be a diameter. Alright, moving right along. If a diameter, if you know it's a diameter, is perpendicular to a chord, then the diameter bisects the chord and its related arcs. So this time you know for sure it is a diameter, and it is perpendicular to another chord. Really cool things are going to happen. This part of a chord and that part of a chord, that's going to bisect that chord. It's going to bisect this minor arc here. It's going to, it's going to bisect that chord right here, and it's going to also bisect this major arc here, so that is going to be congruent to that. All kinds of cool things going on, and all I need to do is put like spots on here, and it's going to look like a ladybug. Sorry, random thought there. And the next theorem, in the same circle or congruent circles, two chords are congruent if and only if they're equidistant from the center. So if you have two chords that are the same distance from the center, remember, mark that right angles distance, then the two chords have to be congruent. So our equation in this case would be 5x minus 12 equals 2x plus 6. Add 12 to both sides. 5x equals 2x plus 18. Subtract 2x from both sides. 3x equals 18. X equals 6. Or if you know that two chords are congruent to each other, then they have to be equidistant from the center. So x equals 2x minus 4. Subtract 2x from both sides. Multiply by -1. Okay. Some cool theorems about chords in a circle. This will conclude lesson 10.3 Properties of Chords.